Hi, I'm Adrian and welcome to Jack of Trades. In this video, we will learn how to utilize the power of Node.js by making a WebSocket server to handle our custom push notification feature. I decided to be the one to voice over this tutorial because this topic needs a lot of explaining to do. Suppose you're not familiar with WebSocket. Well, WebSocket is a communications protocol that enables interaction between a web browser or other client application and a web server to facilitate a real-time data transfer. To put it simply, we can implement a real-time feature to our applications using this technology. And without further ado, let's jump right into it. If this is your first time on this series, I suggest that you start from the beginning. So let's begin. What I am planning is to put a Node.js application inside our Laravel app for a start. Though some of you are already familiar with Node.js, I still think that there is a need to introduce you to what Node.js is all about. Node.js is an open-source, cross-platform, back-end JavaScript runtime environment that runs on the Chrome V8 engine and executes JavaScript code outside a web browser. To put it simply, we can write code for the back-end using the JavaScript scripting language. Now, let's create a folder inside our Laravel application. Note that you can name this folder any way you want, but in our case, let's just call this folder WebSocket. Before you can run a Node.js application on your computer, you need to install Node.js first. You can look it up on Google or just go to the video description because I've put the Node.js download link there. If your installation is successful, open up a new terminal and run npm-v, and you will be able to see the version number if there was no issue with the installation. I am using Windows OS at the moment, but you might be running on a different operating system such as Linux or Mac. But it's going to be pretty similar, so I don't think you will have any issues regarding the installation. What I want you to do is to cd to the root directory of our WebSocket folder. In this folder, we will write the JavaScript file that will serve as our WebSocket server. To start any Node.js app, you will have to create a package.json file. You can generate a package.json file by typing in npm init on your command line. You can also add the $y option to generate the package.json file instantly. But if you just type in npm init and press enter, you will see a series of prompt messages on your command line. You can just press enter until it doesn't show up anymore. After the prompt, you will see a package.json file inside your folder. The package.json file contains the information of your Node.js application. If you have this file in your Node app's root directory, you can easily download other Node.js packages, which we will do later. Before I continue, I would just like to apologize to all of you guys because I know there are many annoying chickens in the background. That is why I have Bailey to take over the tutorials voiceover most of the time, because I can't seem to find a way to get rid of those pesky chickens. I hope the sound of the chickens does not annoy you as much as I do. I know we all have to put up with these annoying chickens if I voice over the tutorials from here on. So enough with the chickens, let's go ahead and delete this package.json file and try to type npm init -y just to show you another way to generate the package.json file. When you start building applications in Node.js, you will most typically see that you will have to make a server beforehand when you create any Node.js app. Unlike PHP, we already have Apache servers or Nginx to run our PHP applications. That is why most beginners would find a hard time understanding Node.js architecture and adjusting to asynchronous programming. But don't worry, everything will make sense once we start writing our code. And I need you to rename your application like so. Otherwise, Node.js will return an error just like you see on the screen. I want you to type in your command line npm install WebSocket space html-entities. The WebSocket is a Node.js package that lets us quickly write a WebSocket server. and the HTML entities is just another helper package that encodes and decodes HTML characters. As you can see, after we downloaded the dependencies via npm install, we can see another file called package.lock.json, and in our package.json file, we can see the WebSocket and HTML entities being added as the dependencies. We don't have to worry about them for now because what matters is we will be able to start writing the code for our WebSocket server. Now let's create a JavaScript file and let's call it event notification server. It doesn't matter if the file name is too long as the file name is descriptive enough, and that's okay. In the event notification file, we can begin writing our code to instantiate our WebSocket server. Even if it's your first time writing code in Node.js, do not be intimidated because what we are doing here is just instantiating classes and methods. And we are writing JavaScript, so it's not that of a foreign language to you. We also need to instantiate the HTML entities object so that we can use its methods later. I also wanted to share with you that when building a Node.js application, at some point you will come across a situation where you have to go to the npm.js website to find a specific package that you may need in your project. Typically, you will see the implementation from each Node.js package that you open. When you get used to downloading packages, you won't be uncomfortable working with them. So the next thing that we wanted to do is add a port number. We needed to specify a port number to run our application. You can refer to the list of available port numbers in Wikipedia. In our case, we are using port number 3280. You can try experimenting with other port numbers as well. Next, we will create another variable to hold the objects of each currently connected client application. We will store the connection object in each array element of the client variable. Please think of this as a list that we use to keep each computer's information connected to our WebSocket server. After that, we will create the HTTP server. The next thing that we want to do is to tell Node.js to listen to this server instance that we just created. By writing the server.listen function, we are actually telling Node.js to start our server. The server.listen variable takes two parameters. The first one will be the port number, and the second one is a callback function. We're not going to do anything inside the callback function other than displaying the information that our server started. Just follow along. This will make sense later when we actually write the meat of the code. Now that we implemented the most typical setup of a Node.js application, we still need to do something because we all know that the code will not run by itself. There are a couple of ways to run a Node.js application or Node.js file. The first and basic one is by typing in node space and the JavaScript file you want to run. In our case, we type in node space event notification server.js. Every time you change something on your JavaScript file, you need to restart the server again. But there is another way to run a Node.js application without stopping and starting the server. There is a Node.js package called nodemon. If you run your Node.js application via nodemon, it will automatically restart your server every time you change something in one of your files. A typical Node.js application only runs one file. You can even put your whole system into one file. But that is not a good practice because if you're building a large application, that will be a big trouble. Eventually, you will have to split your code. To install nodemon, the best way to do it is to install it globally. Run npm install -g nodemon on your command line to install it. The -g that you see means that you're telling Node.js to install the package globally on your computer. In that way, we don't have to reinstall the package every time we start a new Node.js project. Once we successfully installed nodemon, we can write nodemon space and the name of your JavaScript file. In this way, if we change something, the server will automatically restart. I would also like to introduce you to another way of doing this. In your package.json file, you will see a script property. The script property accepts an array of scripts. Notice that we put the same command that we typed in just earlier and assigned it to the property key called start. Now, if we type in npm start on our command line, we should achieve the same behavior. The scripts in your package.json file are just aliases of the actual command. If we have long lines of command for our workflow, we could easily add them to our scripts. To further emphasize this technique, let's create another alias for our command, and this time, let's call it event notification. To run this command, you need to type in npm run event notification because that is the alias that we gave to our script. The start word for the npm start command is a reserved keyword in npm, so we only need to type in the phrase npm start. Now that we have that set up, let's continue writing our WebSocket Server script. This time, let's instantiate the actual WebSocket Server. We need to pass in the server variable to the parameter of the WebSocket Server like so. The next method that we will write will tell Node.js that we accept an open connection to any client application that requests our WebSocket server. Everything inside this function is the actual meat of the code. First, we need to instantiate a connection variable to hold the information of the connection. In our case, we are assigning the connection variable to accept a request from a client application. Remember that our client application is our Laravel app, and our Laravel app will try to communicate to this Node.js WebSocket server later. The next thing that we want to do is pushing the connection instance to the client's array while saving the current index of the existing connection to the index variable. Note that we subtract the index variable to 1 because we need our index to start at 0. Later, when we want to disconnect the specific client app, we will be able to do so using the splice method. And let's console.log the connected client so that we will see the currently connected client application in our command line. The next method that we will write is the actual method that receives the client application's messages. This is the most exciting part of the code because we will achieve that real-time capability for our Laravel application. To test this out, I plan to put a button on our front-end page. I will just use this button to dispatch an event that will emit a listener code to send a static message to our WebSocket server. Of course, we can easily do that with JavaScript and Livewire. After that, we will write a method that will check if the current connection is closed. We can easily detect the client application's connection if it is closed or not through this function. And when it is closed, we need to remove its connection instance from our client's array variable. And in this function, we are using the splice method to remove the client's connection instance. And we also need to console.log to see if the client app has been disconnected to the WebSocket server. And we also need to change this to request. I'm sorry I missed this one earlier. Now, we need some JavaScript code to send messages to our WebSocket server. Remember what I said earlier that we need a button to kind of manually dispatch an event to the server. This time, Livewire will come into play. Open up your Livewire pages.play.php and add another button just beside the create button. We're going to create a function called dispatch event that will actually dispatch a JavaScript browser event. Now, open up your app http livewire pages-class.php and add the dispatch event function that we just called through our wire click. This time, I want you to open up the Livewire documentation and see how the dispatch browser event is being implemented. It is also beneficial that you know how to read the documentation to find this kind of stuff, just in case you forget the syntax. The dispatch browser event function allows you to emit a JavaScript event listener from your backend code. So let's go ahead and just copy and paste this code to our pages class file. The dispatch browser event function takes two parameters. The first parameter is the name of your JavaScript event listener, and the second parameter is the array of data that you are going to pass down to your JavaScript callback function. Of course, we will see this in action once we write the JavaScript code to our front end. In our case, we needed to pass the event name and the event message, so let's go ahead and do that. We will test our code to see if we successfully pass this data array to our JavaScript event listener. And let's call the event notification listener with this dispatch event browser function. And now that we are ready, let's open up our app.blade.php and add a JavaScript code here. In this JavaScript code, let's add an event listener called event notification. In the meantime, let's just put an alert to check if the data that we are passing from the backend is really there. What we're doing here is that whenever we click the dispatch event button, we should be able to fire a function called dispatch event from our backend code that also fires a JavaScript event listener that we just called event notification earlier. So in effect, when we click this, we should see the value of the event name that we just passed in. That is amazing. That only means that we are now ready to write the rest of the JavaScript code. Remember that for us to send messages to the WebSocket server, we needed a JavaScript code to do that. Luckily, the WebSocket API is already embedded in all major browsers, so we don't really need to download another third-party library just to make a WebSocket client. All we have to do is to run a native JavaScript code and we're good to go. So first, I'm going to create a function that instantiates a WebSocket client. This function accepts a config for the domain name or IP and a port number. And if we don't receive any, we will go by the default of 127.0.0.1 with a port number of 3280. When we go to the developer.mozilla website, we should see the basic implementation for the WebSocket client. I suggest that you also check this out because you might find another valuable piece of information to help you in your web development tasks. And now, let's go ahead and continue writing our code. If you're still having a hard time, don't worry. Just follow along and all of these will make sense later. If you notice, most of us are very familiar with the HTTP or HTTPS protocol. We always see the HTTP word on the address bar of our web browsers. We are writing WS to our code this time because the WebSocket runs on a different protocol. Now that we are finished writing our function for the WebSocket client, let's instantiate our client-socket connection. As I said, the function that we just created can receive a domain name or IP and a port number, but for simplicity's sake, let's just leave this blank and connect to port 3280 because that is the default port our WebSocket is running. We also need to check if the connection is open. We can type in connection.onOpen and assign an anonymous function. And inside the function, let's just console.log to see if the connection is really open. Now, let's go back to our web browser and open up Developer Tools to check if we have successfully connected to our WebSocket server. If you see that on your Developer Tools, that is a good sign that we are already connected to our WebSocket server. We can also open up Google Chrome and try to log in to another user. Open up your Developer Tools again and go to the Network tab. Under the Network tab, you will see a sublist of tabs. Click the WS tab, which stands for WebSocket. Here, you will see another sign that we are currently connected to a WebSocket server. If we try to change the port number of our WebSocket server, you will see that our front end throws a JavaScript error that says it can't connect to the WebSocket server. There will be times you will encounter this typical error, so it's also beneficial to become familiar with these kinds of mistakes just in case you see these errors again. Now, for the main event, let us try to send a message to the WebSocket server to see if this stuff is really working. You can send messages to the server by writing connection.send. The send function only accepts string data type. That is the reason why we are using the json.stringify function, so that we will be able to convert our JavaScript object to a string data type before sending it to our WebSocket server. Let's open up our event notification server file again. And for starters, let's try to see the actual structure of the data that we are sending to the WebSocket server by console.logging the message variable. By clicking the dispatch event button, we should be able to send a static message to our WebSocket server. And as you can see, the WebSocket server already detected a currently connected client in real time, and by clicking the dispatch event button, we were able to see the structure the data was sent. To process this message and broadcast this to all currently connected client applications, we will change the code for our WebSocket server accordingly. Here, we just created a UTF-8 data variable and converted the UTF-8 data to a JSON object again, using the json.parse function. I just want to emphasize that we are now writing the code that adds a real-time feature for our Laravel application. Next, we also need to check if the message we are dealing with is in a simple UTF-8 character encoding, and inside this condition, we will prepare the same data again to be sent to all the client applications that are currently connected. Notice that we also use the HTML entity encoding function to ensure that the data we are sending is properly encoded. As you can see, we're just using a simple for loop to send the message to all currently connected client applications, which in our case, the currently opened Laravel apps in different browsers. There will be times that you will also be connecting to a WebSocket server using a mobile app, and the implementation would be pretty similar. Notice that we are using the sendUTF function to send the actual message to our client applications. After this, we should also have some function inside our front-end application to receive the messages that are being sent by our WebSocket server. So let's go back to our app.blade.php and add more JavaScript code there. The connection.on message is the actual function that will receive the messages from the WebSocket server. As you can see, the code for the backend and the frontend is very similar. That is because we're using JavaScript for both backend and frontend. But I hope everything is becoming more obvious to you at this point. I know that some of you might find this to be a giant leap of faith because this tutorial is supposed to be just Laravel 8 and Livewire. But here we are integrating Node.js for our Laravel application. But to tell you honestly, this series aims not only for one tech stack for you to learn. What I am after is that you will be able to realize that in the real world situation, it is very common to use different types of technology in just a single application. So what we did is just console.log on the message that we have received from our WebSocket server. Now, if we click the dispatch event button, we should be able to receive the message from the server. Now that we are able to receive the message from the WebSocket server, we want to have some kind of notification on the upper right corner of the screen to appear. So let's do some tailwind stuff inside our main tag. We also need some jQuery stuff to handle some jQuery stuff later. I am planning to put an opacity animation for this one. That is why I am using Tailwind transform utility. Now, let's display the text that we received from the WebSocket server, and at the same time, put some animation to our pop-up notification. If you're wondering how I am able to do this, that is because I am using the backtick symbol in my keyboard. The backtick symbol is located beside the key number 1 on your keyboard. What we are basically doing here is just adding and removing class to and from our pop-up notification div element, and we will set our div element's opacity to 0 after 3 seconds. Now that we finished this, let's go ahead and try if our code is really working. That is amazing. Congratulations, you just made a real-time feature for your Laravel application. And we didn't even have to use Pusher just to achieve this. What we did is just pure JavaScript stuff from scratch. Of course, The WebSocket API is already native in your web browser. That is why we are able to do this kind of stuff. And also thanks to Node.js. Now, we still have something to do. This is not something that you really have to go with, but in my case, I want my Laravel app to connect to my event notification WebSocket server all the time. Sometimes, you might have to restart your server to resolve a memory leak, and if that happens, all the current connections will throw an exception and will not be able to re-access the WebSocket. So what I wanted to do is that whenever the client computer's connection is closed, I will automatically restart the page. Of course, that would not be very pleasant for some situations because the server might not start immediately and you will have an app that keeps on refreshing every 3 seconds. Now that you have an event notification WebSocket server and a client, you will be able to push real-time notifications to your Laravel app for free. Now, I'm not saying that you should stop using Pusher because of this, because there may be other use cases that Pusher would be much more efficient than making this approach. But if you want a more straightforward and an option that you have more control over, then having Node.js support your Laravel app would be a great option. After all, Node.js is very powerful. The last thing that we wanted to do is add the dispatch browser event to the create, read, and delete method. Note that each client application must have a persistent connection to the server to receive the same notification. So there's one way to have a real-time feature for your Laravel application. But I am not saying that this approach only works for Laravel, because you can also do this with other tech stacks as well. If you enjoyed this video, give it a thumbs up, comment, like, share, and subscribe, and hit that notification bell so you'll get notified whenever a new video is up. Stay tuned, and I'll see you in the next video.